Now we will move on to important part and last topic of this vector algebra, that is coplanar vectors. When do you say that three or more vectors are coplanar? So coplanar means the vectors which lie on the same plane. The vectors which are on the same plane are called coplanar vectors. Look at this. Here is a one plane and there are three vectors. They are on the same plane. So such vectors are called coplanar vectors. Now, under what condition you can say that the given three vectors are coplanar? How to test that whether the given vectors are coplanar or not? So that is what we call as the condition of coplanarity of vectors. Okay. So the three vectors A, B, C are said to be coplanar if and only if their scalar triple product is 0. Why this means? Because actually what I said is in the earlier section, magnitude of the scalar triple product is represents the volume of the parallelopipe. So whenever the volume of the parallelopipe is 0, means all the three vectors will lie on the same plane. Okay, means volume becomes 0. So in such case, the three vectors are said to be coplanar. Okay, so you have to simply say that if the scalar triple product is 0 or the volume of the parallelopipe is 0, then the three vectors will lie on the same plane. So in order to prove the three vectors coplanar, you have to prove that their scalar triple product is 0. Okay, so I will not be proving this theorem. So just I will be stating it. If anybody wants the proof, then please comment. It can be explained. So our aim is to apply this scalar triple product. Okay. Now here is one question. You are asked to show that these three vectors are coplanar. Okay. So what do you have to show? That their triple product is 0. That's all. So we have to show that their scalar triple product is 0. So consider the scalar triple product, which is this, the form of determinant. Expand it and function gives you 0. Okay, so the scalar triple product 0 means naturally the volume is 0. So they lie on the same plane because they does not form any parallelopipe. That is the meaning out here. One more example for your practice. So better you take the screenshot of this example. Show that the three vectors A, B, C are coplanar. You have to do, otherwise it is going to be a tough one and you will not be perfect. Just by listening, it won't help you. Okay. Now from the point of examination, you will be getting examples of this kind. You are asked to find the value of lambda, and given that if these three vectors, vector A, B, C are coplanar. Okay, so we know that when the three vectors are coplanar, their dot product is, that is scalar triple product is 0. Okay, so let's use this. That means the value of this determinant is 0. Expand it. On expansion of this, you will get this. Okay, so the value of this has to be 0 according to given condition. So rest of the thing is just multiply term by term and find the value of lambda. Okay, so here is on expansion you will come up with this simple expression, linear expression, and keep lambda term one side and rest of the constants to the right and simplify, that is 3 lambda minus 2 lambda is 1 lambda, and bringing all these terms this side, 11 plus 3 plus 1, that gives you 15. This is the value of lambda. So remember how to find the value of unknown quantity when the three vectors are coplanar. So here is one more example for your practice. Find the value of lambda if the vectors are coplanar. So the final answer is lambda is equal to 7. You can try. Okay. Now you will be given 4 points and you will be asked show that the 4 points are coplanar. Okay. So when you are given 4 points, you are asked to show that 4 points are coplanar, then what you have to show? That is the thing here. Okay. Means coplanarity of 4 points. Look at this plane. Here there are 4 points A, B, C, D. Okay. And you have to show that the 4 points are on the same plane. So what you have to show is, you have to show the triple product of these vectors, vector AB, vector AC, vector AD is equal to 0. Or you can show that BA, BC, BD, the triple product of BA, BC, BD is equal to 0. If you show in this fashion, then it implies that the 4 points are coplanar. So whenever you are asked to show that the 4 points are coplanar, you have to show that this triple product is 0. Okay. So only A, replacing A is not necessary. You can take instead of A any other vector, any other vertex. You can take BA, BC, BD or CA, CD, CD. You can DA, DB, DC. Okay. The first point or first vertex must be same in all these three vectors. Taking care of this, you can do that any given 4 points are coplanar or not. Okay. So let's have an example on this. Okay. So you are asked to show that the 4 points A, B, C, D with position vectors. These 4 position vectors are given are coplanar. Okay. You are given position vectors of the points A, B, C, D and you are asked to show that they are coplanar. Okay. So one thing to be noted, either you will be given position vectors of the 4 points or you will be given coordinates of 4 points. Okay. So we'll discuss both the cases. So here position vectors of 4 points are given. Okay. So position vector means you are given OA, OB vector, OC vector, OD vector. These are the given position vectors and we have to show that this, the scalar triple product AB dot AC cross AD is equal to 0. Okay, if this is true, then what is your conclusion? A, B, C, D are coplanar. Okay, so let's first find what is vector AB, vector AC, vector AD. Okay, so here are the given position vectors and we want AB. How to find vector AB in terms of position vectors? As I mentioned earlier, you can write OB minus OA. Okay, so OB minus, subtract OA from OB, just in the form of coordinates you can subtract 2 minus 4 and 4 minus 8, 6 minus 12 and respectively you can write I cap, J cap, K cap. So simplification of this gives you this. Similarly, find vector AC, which is in terms of position vector OC minus OA. Okay, so subtract the respective coordinates. So here is the case, and similarly last one, that is vector AD, that you can write OD minus OA. So subtract 5 minus 4, 8 minus 8, 5 minus 12, I cap, J cap, K cap, and this is this. Now the last point is you have to find the scalar triple product of vector AB, AC, AD. Okay. So this is the thing here. So put all the coefficients in this determinant and expand it and you will come up with this. So If this is 0, what is your conclusion is A, B, C, D points are coplanar. Okay, so this could be asked in the exam, was asked twice. Okay, so have an idea of proving 4 given points are coplanar. So one more example for your understanding. The better you take screenshot of this. Here you have to show that 4 points are coplanar. Okay, and their position vectors are given. So on taking screenshot or pause the video and keep working, and I pause the video and keep working yourself. I promise that you will be so perfect in mathematics, you will rock in the class. Okay, so let's move. So better to take screenshot of this also again. Okay, now here is one more and the last problem of this class. Find the value of x such that the 4 points are coplanar. Okay, so here the points are given in terms of coordinates. So better you write first the position vectors. From the given coordinates, you can write position vectors OA as 3i, 2j plus k cap. Similarly for B, C, D, that is vector OB, OC, OD you have to write. Okay. So next you have to find vector AB, that is vector as I said earlier OB minus OA. So just subtract the corresponding coordinates. You can write that is 4 minus 3, x minus 2 and 5 minus 1. So in this way you can find AB, AC, AD, and these are the things. Okay, now you have to find that is scalar triple product, and you are given that if the 4 points are coplanar. Okay, so if the 4 points are coplanar, then the triple product is 0. That is determinant of this is equal to 0. Expand this or using this, solve this equation, determinant equation, you will come up with the value of x. Okay, on expansion of this you get this. Look at this, nothing is hard here. You studied the expansion of determinants in the determinant chapter. So if you are perfect in expanding the determinants, here it is going to be so simple. Okay, so all this very simple, nothing is hard here. So this is how the value of x. So here it ends your theoretical part of vector algebra. So in the next class we will be solving miscellaneous examples in the vector algebra, and we will also solve CET questions and JEE questions. So till then you study this theory part thoroughly. So when you study the theoretical part clearly, if you understand each concept clearly, then cracking the CET questions or JEE questions will not be a hard task. Okay, so without understanding basic concept, you don't try any of the competitive examples. Okay, so take care and we'll come up with fantastic examples. Till then, bye.